on Monday. So you have one more day to review. And if you have any questions or any doubts, today is the day to ask them, okay?
Okay.
We're gonna start talking about the changes of properties.
Science tutorial for students like you. In this tutorial, we'll investigate what happens to different materials as we try to change their properties. By the end of the tutorial, you should be able to explain that not all materials respond the same way when we try to change their properties.
So what are we gonna do here? We're gonna investigate what happens to different materials as we try to change their properties. And when we finish discussing, you should be able to explain that not all materials respond the same way to attempts to change their properties.
Before using this tutorial, it's important to know that matter is all around us. A cloth t-shirt, a piece of wood, a metal bolt, and the pencil and paper you use at school are made of matter. The substances and materials that surround us, that we interact with every day, are made of matter. It's also important for you to know that a force is a push or a pull that's applied to an object. When you push something, you apply a force to the object directed away from you. However, when you pull something, the force you apply to the object is directed towards you. Finally, you should know that temperature is a measurement of the amount of heat energy an object or substance has. One way we can measure a material's temperature is by using a thermometer. Many times, warming something up by adding heat energy will generally result in an increase in the material's temperature, while cooling it down by removing heat energy will generally result in a decrease.
Okay, who can tell me what is matter? Miss. What is matter? Who can help her with that? Say again. Okay, and matter is where? Where we can find matter?
And shirts all around us.
All around. Shirts, you're right. Don't do that because you're right. Everything that surrounds us is made of matter. Force, what is force?
A pull and push.
Will you raise your hand? You. Force. A push and a pull. And temperature is the measure of the amount of heat, energy, an object or substance has.
The material's temperature. With these things in mind, let's explore ways that we can try changing the properties of different materials. We can use our 5 basic senses to make observations about the characteristics of matter. Our 5 basic senses include our sense of sight, smell, hearing, taste, and touch. When we make observations and use these characteristics of matter to describe it, we are identifying its properties. Examples.
Who can tell me what are the 5 senses? Tell me one.
Like, here. Nose. Smell.
Good.
So some properties of matter include color, texture, or state. The color of matter is determined by which varieties of light are reflected by the material it's made of. The color we see when we look at a material depends on how our brain interprets the light that gets reflected into our eyes. You may be familiar with different shades of blue, red, yellow, green, and many other colors. In fact, research suggests that humans can perceive or sense somewhere around 1 million different colors. This means that there may be more colors than we have words to describe them. Texture describes the way that matter feels to touch. You may be familiar with the feel of a rough concrete sidewalk or a smooth glass window. Some other texture words you might use to describe matter could include hard, soft, bumpy, prickly, slippery, or sticky. Another property commonly used to describe matter is its state. Matter around us typically exists in one of 3 common states: solid, liquid, or gas. We can make observations about the shape and volume of a substance to help us determine its state. Studying the properties of different materials can help us learn about the matter that makes up our world and how we might use it in our lives. Imagine you're holding this object to make some observations. What are some words you might use to describe its properties? Now, imagine you're holding a second object to make some observations. How do the properties of this object compare to the first? Identify properties of these two objects that appear to be the same. From the property words listed, select all the properties these two objects appear to have in common, or the same as each other. You can select the speaker icon to have the words on the screen read to you. When you're ready to check your answers, select the green Go button.
Okay. These two objects, we have three properties here. Which properties that you see here are the same in both objects?
Oh.
Color,
I think it's the first one.
Color.
color, what else? We have here state or texture. Are we sure that look at the picture? Do they seem like they have the same texture? Okay. Other rows.
I mean size.
State.
State.
Let's see.
Well done. You could most likely describe both of these objects as a solid blue ball. They both appear to have a blue color, and each of them appears to be in the solid state. However, while one ball's surface appears to be very smooth, the other ball's surface appears dimpled or bumpy. As a result, they most likely have different textures and would feel different to touch.
Okay, so as we see, they share the same color, the same state, right?
Yeah.
Okay. Let's keep going.
One example of using forces to change the property of a substance is sanding. Sanding
Here.
is a process in which a material like a piece of sandpaper is rubbed with a little bit of force very quickly, back and forth across a surface. Sandpaper typically has sand or some other rough substance attached to one side. When the rough surface of the sandpaper rubs back and forth across a material, it can sometimes change the material's properties. For example, wood can sometimes feel a little rough to touch. You may have even gotten a splinter from a piece of rough wood before. But if we rub sandpaper very quickly, back and forth across the surface of the wood, we can change the properties of the wood so it feels smooth to the touch. In this example, the force applied by the sandpaper is used to change the texture of the wood. Not all materials will react this way to sanding. For example, before painting a piece of smooth glass or metal, it's often recommended to use sandpaper to scuff it up or make the surface rougher, so the paint will stick to it better. In this case, sanding makes the texture rougher instead of smoother. Different materials, such as wood, glass, and metal, may react very differently to attempts to change their properties, such as sanding. What property of this block of wood are we most likely to change by rubbing a piece of sandpaper very quickly back and forth across its surface? Select the best choice, then select the green Go button to check your answer. You can select the speaker icon to have the words on the screen read to you.
Okay, based on what we saw, if we use a sandpaper to sand the wood, what is going to change? Isadora.
It's safe.
So if I sand this, the state, the shape of it is gonna, this is gonna change the state, are you sure?
No. Texture.
Texture, let's see.
Texture. Excellent work. Sanding a block of wood by rubbing a piece of sandpaper very quickly back and forth across its surface is most likely going to change the texture of the wood or how it feels to touch. Wood typically becomes smoother to touch when it's sanded, but other materials, such as glass or metal, can react differently to sanding and become rougher to touch.
What did he say? What happens to glass if we sand it?
It could get rougher.
Rougher. So sometimes it can get smooth and sometimes can get rougher depending on what?
And the
Material that we're using.
Have you ever seen a bicycle that's been left outside, exposed to rain over the course of weeks, months, or even years? If so, you may be familiar with a process we call rusting. Rusting typically happens when materials that contain a metal called iron are left in places where they come into contact with moist air. Here's a picture of a new bolt next to a very similar bolt that's been left outside for some time. Both of these bolts are made of steel, a combination of metals that contains mostly iron. Hardware like this often has a shiny gray color, as you can see in the new bolt. However, the iron within the steel can react very easily with water and oxygen in the air to produce rust. Rusted iron changes the bolt's appearance from gray to reddish brown. The way that iron feels can also change during this process from hard and smooth to rough and brittle, meaning flakes of it can break off easily. This means that we can often change the properties of color and texture for metals that contain iron, simply by leaving the material outside.
Okay. Rusting is when iron comes into contact with moist air and forms a rust. What did he say that can change when you leave iron in contact with moist air?
Rust.
Rust, okay. And what changes do you see? What changed the what? Is the same color? No, it says color changes from gray to reddish brown. Is the texture the same?
No.
No? That's right. Texture changes from hard and smooth to rough and brittle.
Here's a picture of a nail made of steel, a combination of metals that contains mostly iron. Which of these property changes are we most likely to observe if the steel nail is left outside, exposed to the weather for a long period of time? Select all the property changes that you would expect to observe about the nail. You can select the speaker icon to have the words on the screen read to you. When you're ready to check your answers, select the green Go button.
Okay. Let's read the answers that we have. The color will change from gray to reddish brown. The texture will change from smooth and hard to rough and brittle. The state will change from solid to liquid. Luciano, come and answer. Which one do you think it is?
The color will change from gray to reddish brown.
Anybody else? Mateo, which one?
The texture will change from smooth and hard to rough and brittle.
Let's see.
Great job!
You guys.
Fidelity.
Outside, exposed to the weather for a long period of time, you might expect the nail to look something like this. The iron in the nail can react easily with water and oxygen in the air to form rust. When iron rusts, its color typically changes from gray to reddish brown, and its texture typically changes from smooth and hard to rough and brittle.
So we see, this is how it started, and then this is how it turns out. The color change and the texture change, right?
Yeah.
Have you ever seen the Statue of Liberty or a picture of it? It's well known.
Yeah,
It's
You haven't
dull
seen it, there's a
bluish-green
picture of
color.
it.
But did you know that the statue did not always have a bluish-green appearance? In fact, when the statue was first built, it was a shiny reddish-brown color, much like the color of a new penny. The Statue of Liberty, or Lady Liberty, as she's sometimes called, is made mostly of a metal called copper. Copper, like many other types of metals such as iron, can react with oxygen when left outside in the moist air to produce a new substance across its surface. In the case of copper, this process slowly changes the color of the metal from its original shiny reddish brown to a darker and more dull brown color, and finally to the dull bluish green color that the Statue of Liberty has today. This color change in copper, called a patina, is a slow process that can take up to 20 years or more. However, take a closer look at Lady Liberty's torch. You'll notice the flame of her torch is not the same color as the rest of the statue. It appears to be a shiny yellowish color. That's because the copper in this part of the statue is covered in a layer of pure gold, a metal that does not typically react with other substances such as oxygen or water. Gold metal is usually observed as having a shiny yellowish color because it does not typically react with other substances such as oxygen and water. The properties of gold metal will not usually change as a result of being left outside exposed to typical weather conditions. In other words, the copper and gold that make up the Statue of Liberty respond differently when exposed to water and oxygen.
Okay, so copper turns shiny reddish brown metal. That's what, if we expose copper to moist air, what's gonna happen? To what color?
To brownish, and shiny.
No. Let's read this again. If exposed to moist air, color changes to dull bluish green. Or a different name for that is called patina. So when copper is exposed to moist air, it's going to change to a dull bluish green. Gold, shiny yellowish metal does not react easily with other substances. If exposed to moist air, keeps its shiny yellowish color. So if we leave gold exposed to moist air, is it going to change or is it going to stay the same? Stay the same.
Shown here are a steel bolt, a copper pipe, and a gold coin. Imagine that these three objects are left outside, exposed to the weather over a long period of time. What changes would we expect to observe in the properties of each object? Drag each object to the box that best describes what you would expect to observe in that material if it were left outside, exposed to the typical weather conditions over a long period of time. You can select the speaker icon to have the words on the screen read to you. When you're ready to check your answers, select the green Go button.
You are gonna answer one. Come and answer one. Reddish brown color, rough and brittle texture. Gold, shiny yellowish color, and copper, dull bluish green color. Let's see.
Well done.
Good job.
You would most likely expect that each of these different types of metal will respond to exposure to the weather in different ways. This is a steel bolt that has been exposed to water and oxygen in the air. The iron within the steel has rusted, which changed its color to reddish brown and its texture to rough and brittle. Here's what a copper pipe looks like when it's exposed to water and oxygen. Its color has changed from shiny reddish brown to a dull bluish green color. Gold, however, is not very reactive with water and oxygen. This gold coin will most likely keep the same properties it began with. Shape and texture are not the only properties of the material that we can try to change. Take a second to look at the color of your clothing. Now, place one of your hands firmly against the fabric, somewhere on your clothing, as we count to 3. Ready? 1, 2, 3. Now remove your hand from the fabric. Do you observe any changes to the fabric? Your clothes most likely appear exactly as they did before your hand touched them. Could you imagine, though, a simple touch from your hand could change the appearance of your clothes? For a short period of time in the early 1990s, a style of clothing became very popular, which used heat to change the properties of fabric. The warmth from your hand changed your shirt from pink to yellow wherever you touched it, leaving temporary handprints all over your shirt. You could watch your purple shirt become blue as you exercised, your body heat raising the temperature of the fabric. This special type of clothing fabric reacted to heat in a way that typical clothing fabrics do not, changing its property of color. Here are two t-shirts that are the same light blue color. However, one of them is made with a typical fabric, and the other is made with a special heat-sensitive, color-changing fabric. Let's see if we can determine which shirt is made of fabric that can change color when its temperature rises. Click on each shirt, touch it with a warm hand, and observe the fabric when the hand is removed. Try to figure out which shirt is made of a typical fabric and which shirt is made of a special heat-sensitive fabric. You can select the speaker icon to have the words on the screen read to you. After you've observed each shirt, select the green Go button to continue.
Okay, now wash carefully the two shirts.
This is what each t-shirt looked like after it was touched with a warm hand. Which shirt is most likely made with a special heat-sensitive, color-changing fabric?
If you think,
Select the shirt fabrically and change
Answer
its
is
properties
A, raise
as a
your
result of a warm touch. You can select the speaker
If you
icon
think it's
to have the
B, raise
words
your
on the
hand.
screen read to you. When you're ready to check your answers, select the green Go button.
everybody say A.
You got it! Shirt A is most likely made of a special temperature-sensitive, color-changing fabric. When the hand touched shirt A, made of the special fabric, the heat from the hand changed the property of color in the fabric, leaving a handprint in a different color on shirt A. This did not happen for shirt B, which is made of a typical fabric that is not heat-sensitive. Changing the color of a special type of fabric is not the only way we can use heat to change the properties of a material. Imagine it's time to fix breakfast, and pancakes are on the menu. First, we'll need to heat up a griddle or flat cooking surface. Next, we'll add butter from the refrigerator. Notice that the butter appears to be in the solid state when it's first placed on the griddle. Since it keeps its shape, it takes up a certain amount of space. As the heat from the griddle warms the butter, you can see it begin to melt, change state from the solid state to the liquid state. In this example, we can even begin to see bubbles of gas form as the butter boils on the hot griddle surface. Next, we'll add the pancake batter, a mixture of materials including flour, sugar, milk, and eggs. Notice that the pancake batter appears to be in the liquid state as it's poured onto the griddle. It takes up a certain amount of space, but changes shape depending on its container. As the pancake batter cooks, it changes from the liquid state to the solid state, resulting in our warm, fluffy pancakes. The butter and the pancake batter reacted very differently to the heat from the griddle. The butter began in the solid state from the refrigerator and changed into a liquid and then a gas when heat was added. The pancake batter began in the liquid state and changed into the solid state when heat was added. Different materials can change their state in different ways when heat energy is involved. Here we have a stick of butter and a bowl of pancake batter. If we place both of these materials on a hot griddle, they will react differently. Drag each material to the box that best describes how it will most likely change when it's heated by the griddle. You can select the speaker icon to have the words on the screen read to you. When you're ready to check your answers, select the green Go button.
Isadora. Here it says changes from liquid to solid when heat is added, and changes from solid to liquid when heat is added. Which one? The stick butter, which one do you think it goes? Either here that changes from liquid to solid, or over there that changes from solid to liquid.
Well done. The stick of butter begins as a solid material from the refrigerator. As heat is added on the griddle, the solid stick of butter will most likely change into a liquid puddle of butter. The pancake batter begins as a liquid that can be poured. As heat is added on the griddle, the liquid batter will most likely begin to change into a solid pancake. The heat from the griddle can result in different state changes for different materials.
Okay, who can give me an example? A different example of something solid that can turn liquid when you apply heat. Fidelity. What? Cake, okay, for cake, that's a good one, but that will go here. Starts like a liquid and then turns into solid when you heat it, but that's the correct answer for this one. Who can give me another example for something solid that changes to liquid? Ice.
Here's a statement about how different materials respond when we try to change their properties. Read the statement and decide if it's correct. Select yes, the statement is correct, or no, the statement is incorrect. The statement is, all materials react the same way when we try to change their properties. You can select the speaker icon to have the words on the screen read to you. When you're ready to check your answers, select the green go button.
Okay, raise your hand if you think all materials react the same way when we try to change their properties. Raise your hand if the answer is no. And the ones who didn't answer anything, what do you guys think it is?
You already answered. Yes, you did. No? I was doing this.
Great job! This statement is incorrect. We explored several examples of different materials reacting differently when we try to change their properties. Sanding a piece of wood can make it smoother to the touch, but sanding a smooth glass surface can make it feel rougher. Leaving an iron bowl outside in the weather can result in a reddish-brown rust forming, while copper will react by forming a bluish-green patina. In each case, attempts to change the properties of these objects can have different outcomes, depending on the material. In this tutorial, we investigated different ways to change the properties of substances and observed how different substances reacted when we tried to change them. We sanded a piece of raw lumber, observing its texture become smoother to touch. However, sanding a piece of glass can scuff the surface and make it rougher to touch. We explored how the properties of different metals can change when they're exposed to water and oxygen in the air over time. We saw that when exposed to the weather, some materials, such as iron and copper, can show major changes in their color or texture, but other materials, like gold, do not usually experience changes in their properties due to typical weather conditions. We also observed shirts made of a special kind of fabric change color when heated, while other shirts remain the same. When we examined the process of cooking pancakes, we noticed that we can sometimes change the state of a material by adding heat. Not all materials change states in the same way. The butter melted from a solid to a liquid on the hot griddle, and the pancake batter changed from a runny liquid into a solid pancake with the heat from the griddle. In each of these cases, we saw how different materials can react very differently when we try to change their properties. Thank you for using this original tutorial.
Okay, so who can tell me overall what we learned here? Again, the pancake batter turns into what? The pancake batter, when you put a pancake batter or something in it turns into what? Are you sure? Into a solid. It starts as a liquid and it turns into a solid. Yes or no? Yes or no? Yes? Okay. Overall, what we learned here is that different materials can react very different when we try to change their properties. Anybody has questions? No? surface where you're heating it. Because if you don't put butter or something there, your pancake is gonna stick and it's gonna burn. Exactly, you don't want that to happen. But when it's done, you can put butter on top and see how it melts. And it turns from a solid to a liquid in top of your pancake.
You might have to put the pancake in the microwave so it can melt.
If it's out of the stove and it's really hot, you put butter on it, it's gonna melt. You don't have to put it on the microwave.
So how does the butter not make it so the pancake can't stick?
When it melts, and it creates like a grease on the pan and it doesn't let it stick.
That